Okay, so here we are back at the Enoch Graben, right? So we can turn that on. Um, and so we've got this little watershed that similar to the one that I presented in the last video. But at the end of that video, we kind of ran out of ideas for how do we locate these features along this route. There was some issues with ArcGIS Pro in doing that. And also, how do basically students go about plotting a profile for the river? We were able to do that, but how do you go and export that profile is an important question. Um, because we can create a profile very easily, like we see down here, um, by basically doing what was shown in these videos by Will Almondine from Middlebury College, where you basically use the tool uh, that's called interpolate shape. So if we basically go into the toolboxes, we go to 3D Analyst and 3D Features and interpolate the shape of that line, basically intersect it essentially with the 3D surface, give it Z values, then we can make this profile. And you just simply see it's intersected, and so once we've done that, it's basically called a polyline Z. So if I look at the attribute table for this one that's been intersected with that, it says polyline Z. And then you can right click and under create chart, this profile graph appears, and that's an option. And I've already done that, so I can open that up. That's what's here. But unfortunately, this is not easy to export. So the export as graphic. And that's fine for visualization, but it's not a quantitative tool. And so if you want to be more quantitative, we need another solution. The solution is instead of interpolating, is to create a stack profile from that line. And that's also a tool within here. So stack profile. So if I click on 3D Analyst Tools, that's under 3D Intersections. So we stack profile. And so I guess you don't have to do stack profile. Probably one of these intersect 3Ds will work as well. But this would allow you to do it with multiple data sets if you wanted to. And so I've done that. And what you do essentially is you input the line feature that you want to stack. So you can choose any one, and then you choose the target, which is what DEM are you going to profile, and it could also be a raster difference map, but it must be some sort of raster. And then it outputs it as a table. And so that's what's shown down here. And I've already plotted it. So in that case, you go create chart and choose a scatter plot, and then it'll do that. And I've already done that here, I believe. No. So let's open that. So here we can see the scatter plot, and there's some lines on it. So that's quite nice. I'll show you about that in a minute. So yeah, so make a stack profile, export the table, right click on it, create a scatter plot, and choose the variables, the distance and the Z, and we get this profile line. To make it look good, I would say you want to turn off the trend line because we're not trying to show a trend. This is data. And then I would tone down the size of the points to 1 so it looks more like a line. And there you have it. Now, of course, if you go to export here, it still only allows for exporting as a graphic. But if you go back to the table, you can see it has all the data here. And so you can just right click, go to data and export as table. When you go to do that, what you're going to need to do is make sure that you don't save it within the geodatabase. You want to back up outside of the geodatabase and save it as a CSV or something like that. I think if you click on the info here, you'll see the options are CSV or text. So we could call it, let's see, Enoch profile dot CSV. Okay. And then we should be able, it opens it here, but we should be able to also open it anywhere, like in R or Excel, in which case you can customize it how you want. So I'll let you figure out how to do that. The other things that I've shown here are these points. So you can see these points that I've located along the stream. I'm going to turn off the kind of difference map here, which is nice because you can see the Graben, but this way you just see the hillshade. And so I've located those points at kind of areas that I think might be of interest, where this weird stream enters, where the Graben starts, where this other stream enters, where this stream enters, where I think there's a big jump in the elevation, which might be a sort of associated with my stream profile features, and then this other stream. So I've got these points, and what I want to know is where they sit along my stream profile, right? How do they match up with these features? And so the way to do that is to make your line a route, and then after you've made it a route, you locate these features along the route. So if we go back to geoprocessing, that's under linear referencing tools. So let's see if we can find that. Linear referencing tools. We first create a route, and then we locate features along the route. So to create a route, you would input the line feature. And one of the issues that students have already tried this have run into is that if you choose lines that are sitting in the geodatabase that's by default used, they're not coming up with a route identifier field. And so this tool was built before geodatabases apparently, and it works much better with certain types of feature file types than others. And so what you may need to do if you don't get a route identifier field, which is required to run this, then you need to probably first export the feature as a shapefile. And so remember, to do that, you can just simply right-click on the data, export features, and the key is to change the location. So let's get it outside of the geodatabase, and we call it line.shp for shape. Add it. There is my line, okay, that just showed up. Now, if I input line, we're going to see that there is now a route identifier field, and it can work to create a route. So let me turn off a few of these things for the moment. I have so many lines on here because it took me a while to get this to work properly. So there's our red line. So we're going to make that a route. Right now, it's not yet a route. And essentially, a route means it has a starting point and an ending point. And we need to change this coordinate priority to match what we have here with our profile. So we can see our profile's origin is up in the high topography, which is actually up here. And that's in the lower right of our screen. And so we need to change this coordinate priority to lower right corner. And now we can make this route. So this can be saved to the geodatabase. Of course, it can be saved outside too. So I'm going to call it line route. And go ahead and run that. Okay. Now, check it out. You can make this thing an arrow if you want, and it'll also kind of show you that route, right? It's going out that way. So it starts up here and goes that way. Okay, so then after we've created a route, we can locate features along a route. So you could locate any feature that's a point. And so these features that I've created are called nick zones. And I'm locating it along this line route, and does require you to choose this route identifier field again. This search radius is important because if you didn't put the points right on the map, then if you don't have any search radius, then it has to be snapped. But this is probably more important to have a search radius because imagine you had homes nearby a road, and you want to see where they sit on the road to tell you directions or something like that. Where are they closest? And so we can enter an arbitrary search radius, say 30 meters or 300. Doesn't really matter as long as you know your features that you want to locate are within that radius. Anything outside of that radius will not be included. Anything within that radius will be included at the closest point within the radius to the stream. And that's how it will be located. Okay, and you see the measured field is the distance, it's called mesh, along the route from 0 to over 5,500 meters. So we can run that. And then what that does is it creates a table. If I open that table, we see each of the features that I have and their measured location along that route. So that's pretty cool. So we can pull that out, which is cool. And we can do a couple things with this. So we could either export these features and plot them in R along your profile or Excel or some other program. But there is a way to get it to plot on here as well. And so what you would do in that case is we can go into the properties and we can go to guides. We can add a guide and we can call this, you could say have a, I don't know, stream join 1. And that happens up at, if we look at here, we're 1434 meters. 1434. Yeah, so there it is. 1434 stream join 1 is right there. It's not on this nick zone. Let's add my next guide. So my next guide is this 1940 meters. And that we're just going to call incision initiation. Because if we zoom in, we'll see where this kind of arroyo has formed. If you prefer, maybe that's a better way to call it. Arroyo. Boom. And there, look, the arroyo plotted right there. And so we could add another one, right? So 2157 is stream join 2. And not much is going on there. But you get the idea, right? So you could plot all of these events along your profile and then go ahead and export it as a graphic. And then it's visually and quantitatively sound for their location. Okay, so I hope that helps you. If you have any need for help with plotting this up in Excel instead, let me know. I can try to help you on that. Thank you.